Welcome to lesson 8. Today we are going to be looking at alcohols, phenols, and ethers. Alcohols, phenols, and ethers are important classes of organic compounds that contain hydrogen atoms bonded to carbon atoms. They exhibit unique properties, structures, and nomenclatures, as well as distinct behavior in terms of hydrogen bonding, solubility, and acid-base properties. Let's look at their properties, structures, and nomenclature, starting with alcohols. Alcohols have the general formula ROH, where R represents an alkyl or array group. They contain hydroxyl functional group attached to a carbon atom. We have primary alcohol, secondary alcohol, and a tertiary alcohol. Let's look at phenol. Phenol is denoted as AROH, where AR represents an array group. The hydroxy group is directly attached to a benzene ring. For example, we have the phenol, we have the trichlorophenol, we have the 4-bromophenol. Let's look at ethers. Ethers represented as ROR or AROR, depending on whether alkyl or array groups are involved. They are characterized by an oxygen atom bonded to two carbon atoms. For example, we have the dimethyl ether, methyl ethyl ether, diethyl ether. Let's look into hydrogen bonding and solubility of alcohols and phenols. Alcohols and phenols form hydrogen bonds due to the presence of hydroxy group. They exhibit strong intermolecular forces compared to hydrocarbons. They have high boiling points and greater solubility in polar solvents like water. Shorter chain alcohols are miscible with water, while longer chain alcohols show decreasing solubility. Let's look at the hydrogen bonding and solubility of ethers. Ethers lack the hydroxy group required for hydrogen bonding. They have weaker intermolecular forces and lower solubility in water. They are commonly used as organic solvents. The most commonly used ether solvent is diethyl ether. It has a low boiling point and is highly volatile, making it suitable for various laboratory applications such as extraction and as a reaction solvent. Other ethers such as tetrahydrofuran and diazine are also commonly employed as solvents in organic synthesis and laboratory work due to their ability to dissolve a wide range of compounds. Let's look at the acid-base properties and reactivity of alcohols and phenols. Alcohols and phenols have weak acids capable of donating a proton. The presence of the hydroxy group can allow them to donate a proton. In certain circumstances, exhibiting weak acidic behavior. Phenols are more acidic than alcohols due to the electron withdrawing resonance effects of the benzene ring. Reactivity involves oxidation, dehydration, and substitution reactions. Let's look at acid-base properties and reactivity of ethers. Ethers are relatively unreactive under normal conditions. That simply means that ethers typically do not undergo significant chemical reactions in the absence of specific conditions or reagents. Now, in comparison to alcohols and phenols, ethers are less likely to undergo reactions such as oxidation, dehydration, or substitution without the presence of certain catalysts or high energy conditions. Our next class will be aldehydes and ketones.